a robot unveiled in China moves so much like a human that the company had to release a video after its debut to prove that really, in fact, was a machine. It wasn't really a person.
China moved first with robots, and America's response caught everyone off guard. Not because America was slow, but because America was invisible. While Beijing staged the most dramatic technological spectacle the world had seen in decades, robots that moved like humans, fought like soldiers, and patrolled streets like police, American companies were doing something else entirely. Something quieter, something that almost no one noticed. No press conferences, no stage dismantlings, no viral footage. Just deployment, just data. Just millions of real-world operational hours accumulating in the background, while the rest of the world watched China's highlight reel. Two superpowers, two completely opposite strategies, both convinced they were winning.
We believe we don't need to do anything more to prove that it is definitely an option, right?
Here's what neither side is telling you. The gap between them isn't widening in the direction most people think. And the decision that may have already settled this race, it wasn't made on a stage. It wasn't announced. Most people still don't know it happened. Stay tuned as we uncover more about this story. China chose visibility. In November 2024, Xpeng walked iron onto a stage in front of a live audience. And something strange happened. The room didn't cheer. It went quiet. Not because the machine looked futuristic, because it looked human in a way that made people uncomfortable. Iron stood 178 centimeters tall, with synthetic skin that responded to touch and pressure. Its 82 degrees of freedom produced movements that felt biologically informed, not mechanically programmed. When it walked, weight shifted through hips and knees exactly the way a human body would. When it turned toward the audience and started answering questions in real time, interpreting tone and context instead of matching keywords, people stopped trusting their eyes. The assumption spread within seconds. Someone in a suit. A performer. A trick. Here's the catch. The engineers didn't argue. They stopped the presentation entirely and dismantled iron on stage. Peeled back layers of synthetic skin to expose servo motors, actuator arrays, neural processing boards, and control systems. Layer by layer in front of everyone until there was no suit, no person, no trick. China had crossed a line. Observation alone could no longer verify what was real. Engine AI pushed that line somewhere darker. Their T800 isn't framed as research. It isn't framed as a demonstration. It's a combat platform, full human scale, priced at $25,000 and marketed openly for fighting leagues and defense applications. It strikes with force matching 90% of adult male output and executes martial arts sequences with the kind of precision that doesn't look programmed. It looks decided, like something that made a choice. Early footage hit social media and got dismissed immediately. CGI too clean. The impacts looked wrong in the way that real things sometimes look wrong when you're not expecting them. And get this, Engine AI's response wasn't a press release. It was raw multi-camera footage. No cuts, no edits, no effects. The T800 shattered wooden boards, destroyed training dummies, and moved through combat sequences for 5 full hours on a single charge without stopping or slowing. Then the company announced a humanoid robot fighting tournament. Not virtual, not simulated, physical combat between machines built to overpower each other. At that moment, the line between science fiction and a procurement catalog didn't blur. It disappeared. But here's what the coverage missed entirely. The fighting robots and the lifelike humanoids, that was the performance. What China was doing simultaneously on city streets was something completely different, something quieter, and in some ways, more significant. But the stage performances were only the surface. While the world watched robots fight and answer questions, China was deploying a different kind of machine entirely, and doing it in public, on city. Streets with zero hesitation. Logan Technologies' RTG unit doesn't look like anything from a movie. It's a heavy armored sphere. It moves across land and water at speeds above 35 kilometers per hour. It survives impacts equivalent to 4 tons of force. It carries facial recognition, thermal imaging, and crowd control tools. And it does not get tired, does not need a shift change, and does not hesitate. Footage shows RTG units cutting off escape routes, coordinating with human officers, holding surveillance angles no human officer could physically maintain. Alongside it, the PM-01 humanoid began walking patrols in Shenzhen, moving through pedestrians, responding to commands, rotating its torso 320 degrees for constant situational awareness, running on open-source software so its capabilities could expand without waiting for a manufacturer update. Now, here's where it gets strange. These aren't pilots. These aren't experiments. China stated official timelines for nationwide expansion. AI-powered robotic police across most major urban centers by late 2026, within 2 years, not someday, 2 years. Every security contractor, every defense ministry, every robotics lab watching those deployments started running new projections overnight. Not because China had proved its robots were perfect, because China had proved the world was ready to accept them, whether they were or not. That psychological shift, the reshaping of what people believe is possible on a realistic timeline, that's not a side effect of the strategy. That is the strategy. Here's the catch. It worked. Investment accelerated. Engineering talent moved. Development cycles compressed across every competing country simultaneously. China had effectively written a deadline for the rest of the world. And the deadline wasn't announced, it was demonstrated. But while every major robotics program was recalibrating to respond to what China was showing, something was already running at scale, somewhere else. Something that had been running for months. Something that had quietly accumulated more real-world operational data than any of the demonstrations on those stages would generate in years. Nobody had filmed it. Nobody had live-streamed it. Nobody had written the headline. Because it didn't look like news. It looked like people getting rides. America chose invisibility. No stage, no viral footage, no robot police, no announcement, just cars with empty driver's seats pulling up to ordinary people on ordinary streets, taking them wherever they needed to go and working well enough that the riders stopped caring about the technology. That was the move. If this kind of analysis is what you're here for, the kind most people completely miss, subscribe now. This is exactly the story the headlines don't tell. Waymo didn't announce a robo-taxi future. It built one, quietly, over 15 years. Starting inside Google in 2009, when autonomous vehicles were still science, fiction, grinding through every edge case, every sensor failure, every software regression that real roads could produce. Without press conferences, without tournaments, without dismantling anything on stage. By April 2025, Waymo was completing 250,000 paid rides every single week across Phoenix, San Francisco, Los Angeles, and Austin. Not test rides, not beta access for journalists. Ordinary people commuting, running errands, meeting friends for dinner, inside cars with no one at the wheel. And get this, the safety data wasn't close. Waymo's fleet recorded 80% fewer crashes than human drivers across billions of miles of real operational data. Not similar performance, not roughly equivalent. Measurably, significantly, statistically superior outcomes. Generation 6 sensor systems rolling out through 2025 reduced hardware costs while holding safety performance steady, cutting per vehicle costs and unlocking faster expansion. London comes later this year, Las Vegas, San Diego, and Detroit shortly after. Growth isn't waiting on a breakthrough, it's waiting on the next city approving the paperwork. Here's what that represents that China's strategy doesn't, yet. Every one of those 250,000 weekly rides is a data point. Every near miss avoided, every construction detour navigated, every unpredictable pedestrian handled without incident, feeds back into a system that gets harder to replicate with every passing week. You can't buy that data. You can't simulate your way to it. You can only earn it by deploying into the chaos of real cities and letting the real world teach your system what no controlled test could. That's the wall China will eventually hit. And it's closer than most people think. But first, the factories. The factory floor that forgives nothing. Here's something most people don't understand about automotive manufacturing. The floor doesn't care about your demo reel. It doesn't slow down for a software patch. It doesn't stop because your robot had a bad day. When BMW opened its South Carolina plant to Figure AI in late 2024, the production managers didn't set up a demonstration area. They put Figure 02 directly into live production, 10-hour shifts, fixed quotas. Human workers driving forklifts feet away, handling power tools inches from the robots, filling the air with heat, noise, and vibration. The kind of environment that exposes weak systems within days. Figure 02 ran for 5 straight months without a single unplanned shutdown. Not one. 5 months. In a live automotive plant, 16 joint hands handled precision assembly. 6 body-mounted cameras tracked motion across crowded lines. Production managers who started the trial watching the robots closely stopped watching them closely within weeks because there was nothing to watch for. The machines simply worked. Figure AI didn't stop there. Early 2025, Figure 03 entered production with pressure sensors sensitive enough to register a 3-gram change, meaning it could handle components so fragile that human hands sometimes couldn't. Cameras built into the palms fed real-time visual data during manipulation, closing the loop between sight and touch in a way that earlier models couldn't match. And get this, the Helix control system changed how the robot learned entirely. Show it a task once. It extracted the underlying structure of what it was watching and reused that logic across similar tasks without being reprogrammed. Late 2025 footage showed Figure 03 cleaning tables, folding laundry, washing dishes, and organizing workspaces, using motion that didn't look mechanical. It looked considered. The company set a target of 100,000 units across factories and homes within a few years. The same machine building cars during a day shift could load a dishwasher that night. The goal wasn't impressive footage. The goal was to become invisible, to blend into daily life until people stopped thinking of it as a robot at all. Boston Dynamics made a quieter move in the same direction. The hydraulic atlas that once dominated every viral robotics video retired, replaced by a fully electric version that doesn't try to look human and doesn't try to move like one either. Joints that rotate beyond biological range. Limbs that move in directions a human body cannot. Motion optimized purely for efficiency, not for familiarity, not for comfort, not for cameras. Recent trials showed the new Atlas selecting parts from warehouse shelves, adjusting grip based on weight and geometry, delivering components to assembly stations, all without remote control, perception, planning, and execution entirely on board. Hyundai, which owns Boston Dynamics, began preparing large-scale factory deployment, not a pilot, preparation for scale. Now, here's where it gets interesting. Tesla looked at this entire landscape and saw a manufacturing problem, not a technology problem. In 2021, Elon Musk said Tesla would build humanoid, robots cheaper than cars. By 2025, that wasn't a punchline anymore. Optimus Generation 2 stood 5 feet 8 inches, weighed 125 pounds, walked at 5 miles per hour carrying 44 pounds, and offered 11 degrees of freedom per hand. Enough for delicate manipulation that most factory tasks require. It moved 30% faster than earlier builds, performed deep squats without losing balance, and demonstrated enough tactile control to lift eggs without cracking them. Here's the part that matters most. Optimus didn't start from zero on intelligence. It ran on Tesla's self-driving vision stack, a system trained on billions of miles of real driving data, adapted into spatial reasoning and object handling. That's a data inheritance no competitor built from scratch in a lab could replicate. Tesla produced 5,000 units in 2025 and deployed every single one inside its own factories first. Internal stress testing before external rollout. The same discipline that built reliability into its vehicles. Long-term. Price target. Under $30,000. That's not a research tool. That's a business purchase decision for a mid-sized company. But here's what nobody expected from China's manufacturing answer. China's factory response. While American companies were building robots that could survive automotive plants, Unitree was solving a different problem entirely. What happens when the robot runs out of power? Walker S2's answer was elegant. Every 90 minutes, the robot navigated to a charging station, swapped its depleted battery for a fresh one, and went straight back to work, without human help, without interruption. The production line never paused. No shifts, no overtime, no tired hands at the end of a long run. Backed by confirmed orders exceeding $112 million, Walker S2 was already operating inside real factories worldwide. Binocular vision systems handled fragile electronics with accuracy that regularly exceeded what human hands could deliver. The control system planned task sequences, adjusted workflows dynamically, and predicted maintenance needs before anything broke. Clients already on the books: BYD, Volkswagen, Audi, Foxconn, SF Express. Production targets: 5,000 units per year by 2026, 10,000 by 2027. And here's the catch: those targets aren't projections. They're schedules the company is currently meeting ahead of pace. The 2026 to 2028 window is when these two manufacturing strategies will collide in the same global markets. And that collision is already being prepared for, not in boardrooms, but in the infrastructure of the world those robots will move through. The three-dimensional frontier. China's most audacious bet wasn't on the ground at all. In late 2024, Xpeng unveiled the A868, a 6-seat tilt-rotor flying vehicle designed for vertical takeoff and landing. It lifts straight up, transitions to forward flight like a fixed-wing aircraft, and lands in spaces barely larger than a parking spot. Claimed range: 500 kilometers. Top speed: 360 kilometers per hour. Electric motors handle low-altitude urban movement for noise reduction. A range-extending system handles the long haul. Now, here's where it stops being theoretical. More than 6,000 customers placed real deposits. Production slots locked with real money. Delivery scheduled for late 2026. That timeline means actual vehicles, piloted by real people, flying over real cities. While most countries are still in committee meetings debating airspace regulations, China isn't waiting for the debate. It's already building vertiports, already drafting low-altitude air traffic rules, already training pilots, working with insurers, building the ecosystem the vehicle will need before the first delivery lands. The A868 isn't a flying car. It's the first component of a three-dimensional transportation layer, and it's arriving whether the rest of the world is ready or not. Building the world that robots inherit. Here's the thing about building better machines that almost nobody talks about. The machine is only as capable as the environment it operates in. A robot that navigates a spotless factory floor flawlessly may fail completely the first time it hits a flooded underpass. An autonomous vehicle that handles a structured highway may break the moment it faces an unmarked rural road. The real strategic edge isn't just smarter machines. It's shaping the world those machines inherit, so the variables are reduced before the robot ever leaves the factory. China understood this early, and it built accordingly. The Shenzhen Junction Link is what that understanding looks like at full scale. A 24-kilometer corridor combining bridges, undersea tunnels, and artificial islands into a single integrated route. Engineers worldwide called it impossible. It cost approximately 44 billion yuan and broke 10 world records. At its core, an immersed steel shell tunnel stretching 6,845 meters, the longest and widest of its kind anywhere on Earth. 32 sections, each weighing 80,000 tons, floated into position and lowered onto the seabed with millimeter precision. Inside the tunnel, a 5-kilometer utility gallery carries power, water, drainage, firefighting equipment, communications networks, and structural health sensors running continuously. 14 autonomous inspection robots patrol without stopping, scanning for cracks, corrosion, and deformation long before any human could spot trouble. Dual wavelength flame detectors, horizontal smoke extraction that boosts evacuation efficiency by more than 40% compared to conventional systems. Dynamic light strips that guide drivers through emergencies by color shifting from white to yellow to red to green toward exits. Before the link opened, the drive between those cities took nearly 2 hours. Now it takes 30 minutes. In the first month alone, over 3 million vehicles crossed. And get this, China isn't the only country redesigning the physical world for machines. Germany embedded wireless charging coils into road asphalt. In Balingen, working with Electrion, electric buses now charge while driving. Copper coils beneath the surface feeding receiver coils under the vehicle, no stops, no cables. The concept scaled to the Bavarian Autobahn. a 7.5 million euro trial charging vehicles at full highway speeds up to 130 kilometers per hour. The road itself became a power source. Norway went after geography. The $40 billion E39 project eliminates 7 ferry crossings on the western coast using bridges and tunnels. The most extreme section, Rog Fast, 27 kilometers long, descending 392 meters below sea level, the deepest underwater road tunnel ever attempted. Halfway through, there's a functional roundabout carved into solid rock, hundreds of meters beneath the open seawater. Where tunnels won't work, Norway is testing floating tunnels, submerged concrete tubes held by tension cables anchored to the seabed, letting ships pass overhead while traffic moves below. Dubai turned infrastructure into performance and visibility. Commercial drone delivery launched in December 2024 with a target of 70% city coverage by 2030. Air taxis begin late 2026. Police already deploy hoverbikes hitting 100 kilometers per hour through traffic. Here, technology is supposed to be seen. The strategy is the opposite of invisible. It's demonstrative by design. Each country building a different operating environment for the same technological future. Here's what that means for the 2026 to 2028 window that's already approaching faster than anyone projected. The verdict. The race didn't produce a winner. It produced 2 simultaneous victories on different playing fields, and the second half is when they collide. Let's be precise about what each side actually won, because the mistake most people make is treating this as a single competition with a single score. China's visibility strategy worked exactly as designed, when iron had to be dismantled on stage 2. Prove it wasn't a human. Every engineering team worldwide reopened its roadmap and its budget in the same week. When the T-800 fighting platform went on sale for $25,000, defense procurement officers who'd been treating humanoid combat robots as theoretical started treating them as near-term inventory. When robot police deployed in Shenzhen with stated expansion timelines, the policy conversation moved from academic journals to government briefings inside of months. These weren't just demonstrations, they were compression events. Moments that forced the entire global industry to accelerate on China's timeline rather than its own. When one country resets the global expectation of what's possible, every other country has to respond at that pace or fall behind. That's not a side effect. That's the architecture of the strategy. America's answer was built on a completely different logic. And here's the catch. It may be more durable. When 250,000 passengers per week take rides in, cars with empty driver's seats, and those cars record 80% fewer crashes than human drivers across billions of operational miles, you're not watching a demonstration anymore. You're watching infrastructure. That kind of data doesn't come from a stage performance. You cannot buy it. You cannot simulate it. You earn it by deploying into messy, unpredictable reality and letting the world teach your system what no controlled test environment could replicate. You cannot fake endurance. Every operational hour in real conditions generates failure mode data, edge case data, resilience data, the kind of accumulated knowledge that becomes harder to replicate with every passing month. The lead compounds. But here's where it gets complicated, and why the 2026 to 2028 window matters so much, and why you should be paying close attention to it right now, not in 2 years. China must carry its robots from controlled demonstrations into the kind of continuous public operation that earns the data advantage. That translation is the hardest step in advanced technology deployment. The gap between theatrical capability and sustained endurance under real-world pressure, that's exactly where ambitious programs most commonly collapse. The robot that impressed on a Shanghai stage might not be the robot that survives 10,000 unpredictable operational hours in a factory in Stuttgart, or on patrol routes in cities where the infrastructure wasn't built to accommodate it. Impressive is easy, reliable across millions of cycles in conditions nobody staged. That is an entirely different engineering problem. Now, here's where it gets strange. America faces the mirror version of the same problem. America must match Chinese manufacturing speed and cost efficiency before the price gap becomes a market share gap that's impossible to close. Even the most reliable robot is commercially irrelevant at a price point that only large corporations can justify. Optimus targeting sub $30,000, and Walker S2 meeting 10,000 unit annual production targets by 2027 are both attacking the same economic problem from opposite directions. Whoever closes the cost-volume equation first gains adoption leverage that compounds just as relentlessly as operational data does. Supply chain control, AI training advantages, regulatory frameworks shaped by whoever accumulates safety records first, export competitiveness in markets that don't have a strong domestic robotics industry yet. All of it funnels toward the same 3-year window. Flying car deliveries will test whether the ambition survives contact with real airspace regulations, real weather, and real passengers who do not forgive crashes. Robo-taxi scaling will test whether safety performance holds as weekly rides multiply from hundreds of thousands toward millions. Factory humanoids will test whether the economics actually close at scale. Not in 5 plants, but in 5,000 plants across dozens of countries that don't particularly care which flag the robot was built under. They care whether it works and whether they can afford it. Now here's what nobody expected from all of this. The most consequential technology race of this century has mostly been quiet, not the machines. Those are extraordinary. The fighting robots, the lifelike humanoids, the autonomous police, the self-driving fleets, the flying cars, all of it is genuinely extraordinary. But the winning, the actual mechanism of deciding who leads the next decade of global automation, repetition, data, operational hours and conditions nobody staged. China proved you can reshape global belief about what's possible, and use that belief as a force multiplier that compresses timelines, moves capital, and forces every competitor to react on your schedule. That's a real strategic advantage. Don't underestimate it. America proved that belief eventually has to become infrastructure, or it means nothing commercially. You can't sell belief to a logistics company evaluating whether to automate its warehouse. You can sell a robot that ran for 5 months in a BMW plant without a single failure. You can sell 80% fewer crashes across billions of real miles. You can sell a unit price under $30,000 on a timeline that's already in production. Both are right. Both are winning. Both are approaching the same wall from opposite sides. And the wall is the 2026 to 2028 window. Not a metaphor, not a forecast. A scheduled collision between 2 strategies that have been building in parallel for years and are now moving toward the same global markets at the same time. The robots are already working, the infrastructure is already running, the transformation has already taken hold across industries and cities. Most people haven't noticed because nothing theatrical happened in most of it. The cars just started driving themselves. The factory robots just started finishing their shifts. The flying vehicles just started taking deposits. The next chapter of this race is being written right now, and the people watching it unfold in real time, not waiting for the headlines, not waiting for the viral footage, not waiting for someone to announce that something important happened. Those are the people who will understand what comes next before the rest of the world catches up. That's what this feed is for. The 2026 to 2028 window is opening. You'll want to be watching when it does. Subscribe, and you will be. If you found this useful, click the subscribe button.